We're back. I would have made it in 3 minutes, but my dad stopped me. He says, "Yo, Steve." I say, "Oh no." All right, where are we? We are Fahrenheit Friday. Yeah, that could work. Although, I mean, that would work. That's the magic. I say alliterations don't control my life. I control the alliterations. I can turn anything into anything. Batman. Man Bat. Monday. You can't stop me. Alright. Celsius Friday. What are we looking at? The freezing is we're playing tropical freeze music. Tropical Dong, Donkey Kong, Bing Bong. This game has 4 hours of music, so we're set for now, you know? And then we got 4 hours of puzzles, and or 3 hours, because that's how long Sudoku Sunday is. What do we see right away? Any freebies? 5 bottom middle box top left cell. 5, 5, 5. So yeah, we got 3 5s lining up. That puts a 5 right there. Is this how long are these thermometers? 1, 2, 3, 4, 5. Well, there you go. The thermometer has to be the smallest number on the bulb, and it has to keep growing. If the tip of a 5 long thermometer is 5, you just get all the you just get the whole thermometer. I see freebie 9 also. We have, yeah, it's there were a lot of 5s lining up. I see a 9. I see lots of 9s. What can we see? 9, 9, 9. So that's a 9 right there. 9, 9, 9. We get a 9 right there. Nine, 9. We'll have a 9 in one of these 2 squares because these 2 rows are covered. So this box will need a 9 in the bottom here. And we'll get a similar pattern. Oh no, that was this hard 9. Okay. But we will have a 9 on the bottom here somewhere. And a 9 on the edges there somewhere. Based on these 2 9s. And that's all our 9s penciled at least, right? 1, 2, 3, 4, 5, 6. Yeah, so we have the estimated locations of all of our 9s. 9 won't be popping up anywhere else. Oh, I see a 1. We got a 1 in these 2 columns and a 1 in this row. That'll give us a 1 right there. Which will then give us our next one right away in the middle here. Next one mid. Check it out. Boom, boom, boom. There we go. We got a 1 there. Do we get all our 1s? Yeah, well, these 2 1s have these 2 columns covered. So the 1 in this box has to go right there. And then these 1s line up. These 4 1s all intercept with this square slash box. Give us a 1 right in the bulb. Nice bulb is 1. And that's all 9 1s. There we go. Was this what star puzzle was this? 2 stars. Okay, this is supposed to be easy. I can say this is really easy. Seven, 7. Move 7 on those two. Bottom square will have a 7 in one of these two squares based on these two 7s and the rest of the box being filled. That's all I see for 7 right now. I guess we could find out a little bit more about 7 because this 7 covers that row. Then we already know there's a 7 in the bottom row because the only two candidates for 7 are in the bottom row here. So that row's covered, that row's covered. So there'll be a 7 up here somewhere. I can mark a couple 2s. 8 bot left. Oh yeah, there we go. 2 8s lining up. Give us a fat A right there. I see an 8. It's a very sneaky 8. So this 8, when I'm looking at this box, this column is covered by this 8. So we can pencil in an 8 in one of these two squares. There or there. So now these two columns are covered. And now we can pencil in an 8 in this column here for this box. But can an A go on this bulb? Well, if we put an A in the bulb, it has to keep growing. It definitely runs out of space. These are 5 long thermometers. And same thing with this 8. 8, 9, and we can't reach the end of the thermometer. We ran out of space. So we cross out both of these 8s. And by process of elimination, we get a clean 8 right there. We can look at this middle and get only 2 candidates for 8, either there or there. I think that's it for 8 right now. We've looked at 1s, 2s, a little bit. Is there anything going on up here with 2? Not really. 5 mid. Oh yeah, these two 5s. That'll give us a 5 right there. And now I have these 2 9s pen marked. So I get rid of the 1 9 and that we can do the double check. And that's cluing me in. Yep, there it is. We just found another 9. And this 9 will cross out this 9 down here. So there's only 2 numbers missing here. 8 and what else? 1, 2, 3, 4. So we have a 4-8 split. I don't have too many 4s on the board. Only 2. I'm gonna pen in this square also, this box, because there's only 3 numbers missing. We're missing 2, 4, and 6 it looks like. And we're gonna cross out. That's not the 2. That's not a 4. That could be any of the above. We can do the same thing with this row. We can look at what goes in this row. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cross out 7 there. And I think that's it for now. Oh, and we can do the same. This row is probably pretty telling because it's on a thermometer. So we're missing 1, 2, 2 and 3, and 6. Well, this isn't 2 because there's a 2 above it. This isn't 3 because there's a 3 above it. What is the order of the order of these songs is like not like the order of how the game would go. It's like a best hits list. Bot mid bulb is in 6. 6, 7, 8. Yeah, there's not enough space and multiple conflicts, even if we try to force it. So that's not a 6. That's a 2. And before we go any further, also there's another thing we can do. We can look at this 2, 6, and 2, 6. And then that means this can't be a 6 either. Because if we put a 6 here, it would force 2 2s. Or however you want to think about it. Essentially, it's like a split that shares a square resolves this square. So we know that's a 3. And then we also know this wasn't a 6 because of there wasn't enough space. That's our 2. And that's our 6. This 6 will cross out these 2 6s, or these 3 6s rather. We can get 4 and 4, and finish this box off with a 2. And now this row is left with just a 6 7 split. And should we pen in this row? Maybe, there's only 3 numbers missing. 4 bot left. Zoom, zoom, boom. Yep, 4 right there. What song is this? Mangrove Cove Underwater. We'll have a 4 up here somewhere based on these 4s. 3 bot left 2. Oh yeah, 3. So that's our 3. And then what's missing in this box? 1, 2, 3, 4, 5, 2, 6, 7. This 2 crosses out that 2. And then can we cross out a 2 here? We can. I mean, this is on the thermometer, so it has to be bigger than 3, less than 8. Eliminate 2. And now this box only has a single spot that 2 can go. And so we'll put the 2 there. 1, 2, 3, 4, 5. This bottom box is missing 6, 7, and 9. And we can do some crossouts. Like the 9 already saw the square earlier. The 7 sees that. And a 6 sees that. My attention's on this column now. Once again, we have some thermometers which will help resolve a bit. Numbers in this column already are 1, 2, 3, 4. That means we're missing 5, 6, 7. What can we cross out? This 7 shares a row. This 6 shares a row. And this can't be 7. This can't be 7 because we know this square is going to be less than 7 for sure. The only 2 numbers it could be are 5 and 6. If this is 7, then our thermometer is now being forced to shrink. So that won't be 7. And then we can just get 5. Cross out the 5. That gives us 6. Cross out the 6. That gives us 7. And 6 to finish this box off. 7, 8, 9. Yeah, so this is a 6 already on the thermometer. And so this thermometer was, which one was it? This one ended in 5 and had to work its way down to 1. Now this one started in 5 and has to 7, 8, 9 is the only thing that fits anymore. We were only missing 2 9s, weren't we? So, where's our other 9? 9, right down here. That's our 6. Cross out that 6. Process elimination, that's our 7. And then finish the box with a 9. Our last 9. There's 4 8 splits resolved. We put an 8 here. And now we know this is our 4. And that's our 8. And now we have two columns we can finish. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Oh shoot. Ba-boom. There we go. Thank you. I knew I remember the top right box being limited on 4s, and sure enough, this 4 will give us a 4 right there. Boom, 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 boom. Row, row, column, column. What's the last 3 numbers in this column? 1, 2, 3, 4, 5, 6, 7. 2, 3, 7. Well, 7, 7. 7 goes up there. Seven, 7. One, 2, 3, 4, 5. Oh, yeah, so this square, I just figured we can figure it out. Yeah, 1, 2, 3, 4, 5, 6. Could be 7, 8, 9. It has to be 7. Every other choice is taken up. That's the other way. So, I mean, the one way is to find where all the numbers, cross, and you can find some numbers that way. But then other times you can just pick a square and be like, okay, what does the square have to be? Those are the ones that, when you're stuck on a puzzle, and the solution is one of those, it becomes, it can take a real long time. You're just randomly picking out squares. What can the square be? 1 of 5 numbers. What can the square be? 1 of 2 numbers. 1 of 2 of the same numbers. Oh, wow, okay. Oh, speaking of which, we found a 2. These 2 2s. Give us a 2 right there. Three, 4 missing from that row. We have a 4 in this box already. So this will be our 3, and that will be our 4. And then we can finish this box off with 1, 2, 3. Last 2 numbers here. 1, 2, 3, 4. Missing 5. 6, 7, 8. Missing 8. We have an 8 here and a 5 here. So either way we could have seen it goes 8, 5. You can finish this column as well. 1, 2. This 2 will cover this row, resolving this 2, 3 split. That's our 3. Finish the column off with a 2. This row is missing 1, 2, 3, 4, 5, 6, and 8. Kong. This 8. I don't know what that was. Oh, I think that was. Oh, that was like the Wii menu. See, the soundtrack is all out of order. That was the song that plays when you're highly in the game on the Wii menu. No, what is this? How hard is it to put your soundtrack video in chronological order? Whatever. At least it's more variety, I guess. It is confusing though. This column is almost done. 1, 2, 3, 4, 5. Sneaking out a little 6 right there. Only 2 numbers missing here. Oh, and also we can finish this column. 1, 2, 3. Now let's finish this puzzle. We're missing 2 numbers in this row. 1, 2, 3, 4, 5. 2 numbers in this row. 1, 2, 3, 4, 5, and 8. So where do we start? 8. Already in that box. This is our 5. That's our 3. Jump across here. This is our 5. And finish the puzzle. Pause for emphasis. Pause for reflection. Let's soak it in. And that's our 8. Bam. The power of hard metal tropical prong. Yeah, so what's the scaling on this? The normal game scaled from 1 to 40. Well, 39/40. And then there's 5 puzzles added, I'm guessing. And now it's 15 puzzles added. We're back down to the front of the scale. So what's going on here? Couple of little spider legs. 1, 2, 3, 4. Hey, doggone, take it easy. 1, 2, 3, 4. The longer the thermometer, the more restricted it is. A short thermometer doesn't really tell you much. It kind of tells you like where 1 doesn't go, where 9 doesn't go. But after that, like the shorter, the less info you get. Speaking of 1s, we can use that trick right now. We have a 1 in this column, a 1 in this column. So that means we're going to have a 1 in one of these 2 squares. However, as we can see on the, where is it? Right here. On the tip section, the 1 would have to be on the bulb. And we know that just because the rules of thermometer means it has to grow in one direction and shrink in the other. And we can't shrink less than 1. We can use that little trick to limit the 1 in the middle quite a bit. We have a 1 in this row. And then it looks like we have 6 spots that 1 could be. But when we remember that the 1 can't be anywhere on the thermometer except for on the bulb, also when we cross out 4 candidates. And we have a 1 in this column. Lock. As a matter of fact, I mean that's just a tip so you understand the rule, but the extension of this rule is a 2 would have to be within the first 2 squares of a thermometer. Because a 2, and then I shrink to 1, and then we run out of space. So if I look at this 2 now, the 2 has allegedly 6 candidates, but now 2, 1 out of space. For all these thermometers, it's too far along. Cross those 4 out. And we're left with the 2 right there. Same with 3. We got a 3 right here. We'll get a 3 in just one of these 2 squares. And I'm going to put those in the middle. 2, 3 split. I'm saying one of these is for sure a 2. The other one is for sure a 3. But it can go either way. I can't do that with 8 though. If I try to do that trick with 8, we realize we have plenty of room to put an 8 down. 8, 7, 6, 5, 3, whatever. So we can't cross out 8 from these vertebrae thermometer tips. 8 bat right, let's check it out. We have an 8 here and 8 here. So then we have an 8 in one of these two squares. And then yep, this 8 is far too close to the front of the thermometer to be able to reach the end in any amount of time. So that will give us an 8 right there. And then only one number bigger than 8, 9, we can finish the thermometer with that. Very cool, very nice. Does that give us a bonus 8? Yes it does. 8, 8. That puts us 8 right at the bottom. Hit that middle. Yep. I think I beat you to that one with some stream delay. But we both saw it. We can go even further on the 8s. We can look at this box and say this column is covered, this row is covered, and that gives us an 8 in one of these two squares. We'll either have 8 on this side or 8 on this side. In both cases, this row is occupied with 8. This row is already occupied with a given 8. That would give us an 8 for this box in the top here. And then these pencil tricks are kind of cool. They don't get too crazy in regular Sudoku. But when we were looking at night Sudokus where the pieces were also a night move blocking, like you couldn't have a 4 in these squares. When you started having puzzles like that, the pencil marks you would like follow a chain of 8s and then a chain of 8s and then a chain of 8s and like finding like an 8. When you had like one 8, you would like sprawl around the whole board and find another 8. It's really cool. And a cool way to practice pencil mark trickery. Speaking of pencil marks, I'm gonna mark down these two 8s over here. We have an 8 here, an 8 here. 8 will go in one of those two squares. I think is that all of our 8s? Except for in the middle. Where does the 8 go in the middle? One of these 3 squares. Okay. Yeah. Is this the same song still? I'm 28 minutes in the soundtrack. Yeah, this is Albin Punch Bowl. Apparently it's a 6-minute boss song, which the boss fights are around 6 minutes in this game, so I guess it makes sense. I didn't know they would have non-looping music. 6, speaking of 6 minutes, 6 in one of these two squares. Because this column is covered and this column is covered. Boom, boom. And now we actually have a 1-6 split. One of them's gonna be 1 for sure, one of them's gonna be 6 for sure. The way I can tell that is this box only had 2 possible spots for the 1, and also only two of the same possible spots for 6. So one will be 6, one will be 1. We're going to mark those slightly different because it helps. Alright, see ya, mate. We can also finish this off with 5, 7, 8. Couple more pencil marks we can find by filling these rows. Get 2 over there. Get a 4 over there. Get a 4 in one of those two. And a 4 in one of these two. Can this 4 be in the thermometer? 4, 6, yeah, pretty generously. A mid-range somewhere in the middle of the thermometer, not going to be too restricted. This top row is missing only 3 numbers, missing 2. We have the 1, we're missing 2, have 3, 4, need a 5, need a 7. And we can cross out a 2 up here. 7, 8, 9. 7 doesn't fit, we can cross him out. 5, 5, 6, 7, 8. 5 does fit. That means we have to respect the 5. It doesn't mean it is the 5. It means we have to respect the 5 and keep it there. We also have 3s. These are 3s in that spot. Because 3 and 4 are both restricted to the same 2 squares, that'll be a hard 3-4 split. This square is on the thermometer. We know it's greater than 1, and we know it's less than 4, because 4 is the biggest that could be here. So what's greater than 1, less than 4? 2 or 3? Well, we already know it's not going to be 3 because there's a 3 in this row. So that's a 2. And that will actually give us a 2 down here. We have a 2 in this column now. Oh, never mind. We have a 2 in the box. I was thinking we had a 2 and a 2. But no, this box already has a 2. Well, this is a 3-4 split. So what is this box missing? 1, 2, 3, 4, or 4, 3. We just know 3 and 4 are going to be in these 2 squares. 5, 6. So this box still needs a 7. That'll be a 7 to finish off there. This row is covered already. We know there's a 2 or 3 in this middle section here, either here or here. So 2 is covered in this row. And then column, column. That means we'll have a 2 in one of these 2 squares. Is that helpful? Not necessarily. I'll mark it though. It's not unhelpful. Six in one of those 2 based on these 2 6s. 6, 6. We have a 6 in one of those 2. Oh, here's something cool. Let's look at these ones. Where will one go in this box? Here or here? Because it's not going to go on the thermometer. We already know this is 2 or 5. And then that's on the middle of a thermometer, which the one cannot go on. So that's all covered. Now let's look at the bottom. Where does one go down here? Not on the bulb. The bulb is covered. Not there. So here or here. So now when we look at our ones, we have 2 candidates for 1 in this column, 2 candidates for 1 in this last column. So if this column will be covered, if these 2 columns will be covered twice, where does the 1 go in this box? Well, if we go just based off of this one, the only one that sees it right now, we might say, oh, one of these 6 squares. But when we look at the candidates for this column for 1, there's only 2 possible squares that 1 could go in this column. And that's here or here. Which means the 1 in this box will definitely be in this column. That means we can then throw out these 4 ones. And there's a few ways you can think about that. There's multiple reasons why this works. One is the reasoning I just said there. Another reasoning would be, let's try putting a 1 here. We cross out these 2 ones, and we end up with the only one possible legal for this box would be here, and the only one legal for this box would be here, which are in the same column. That's not another way to think about it. But yeah, in either case, we end up with just a 1 in one of those 2 squares. Not bad, you know, for having like a single 1 to find all those pencil marks. Oof. I don't see anything with 3. I didn't see anything with 2 that we don't know already. What about 4? No. How about, let's check out 5. Only 1 5 on the board to begin with. So not going to know much about 5. 6? I think we were looking at 6s already. Yeah, no. Nothing. 7. How do these line up? 7, 7. Well, it lines up with one of these 3 squares in this box. However, let's ask ourselves, can we put a 7 this far back in the thermometer? With no other info we could, because we could do 7, 8, 9 and reach the end of the thermometer, but we already know that's not going to be a 9, and we already know this box has an 8. So we can't do 7, 8, 9. We'd run out of space on the thermometer. That means we can cross out 7 there. And now what do we know? Well, when we look at our pencil marks for this box, they're both in the same row. That means this row is covered as far as 7 is concerned. If we put a 7 here, all of a sudden this box has no possible spot for a 7. So this row is covered. This row is covered. We'll have a 7 in one of these 2 squares. Not too bad. Can we do something similar up here? Let's check it out. We have a 7 and a 7. That gives us a 7 in one of these 3 squares. 7, 8 is legal, so I don't think we get any bonus crossouts. I think we all just get our regular crossouts. Let's look at 8 then. Done looking at 7s. Let's look at 8. No, nothing about 8. 9. Okay, we get a little bit more about 9 when we think about thermometers. Right now, there cannot be a 9 on any other thermometer. We have this one, but he already covers all the tails. So now 9 can't be anywhere else on a thermometer. When you take that into account, all of a sudden, it's a lot easier to start looking for 9s. We have a 9 up here. That means we have a 9 in one of these two squares, because the thermometer is covered and this column is covered. Now that we have a 9 in here, that column's covered, that column's covered, this row is covered. We'll get a 9 right here in one of these two squares. Only 2 possible squares for 9 over here. And we also knew there was only 2 possible squares for 1. That means we have a hard 1-9 split. Uh-oh. Why did I just click? Close. And the way we know that is, we know we're splitting 2 numbers between 2 squares. So even though this could be 6, there's nothing saying this could be 6. The way we know it's not a 6 is because if we put a 6 here, then all of a sudden we run out of space for either the 1 or the 9. We could have either or here, but we will not be able to fit both into this box. So now we get a hard 1-9 split, and that will actually give us a 6, it looks like. We have a 6, we have a 6. The square could have been 6 before, but we know it's not anymore. Bam. That's our 6. We know this number has to be greater than 6, less than 8. This is 8 at the biggest. So that's our 7, and that's our 8. This is a very strong 8 right here. It bounces around quite a bit, it looks like. It crosses out these 2 8s. And now, boom, boom, boom. We get an 8 up there, and boom, boom, zoom, zoom. We get an 8 down there. It's 9 8s. There we go. What about 7 too? We found 7 here. Yep, let's look at this. 7, 7. That's a 7. Seven, 7. We'll get 7 one of these two, and 4, 7, 4, 7. Boom, boom. 4, 7 split. Whoops. We also just found this 7, which, oh no, what's more important is we found this 8. The reason we found this 8 being important, this used to have been a candidate for 7, which meant we didn't know if 7 went here, down here, or if it went over here. But now when we look at this middle box, there's only 2 possible squares for the 7, here and here. That means this column is covered. Let's turn this back up again. Ooh, this is my jam. We got 2 7s here. That means this column is covered. If we tried putting a 7 here, no place for a 7 in the middle box. There's just not enough space. Cross out that 7, we get a 7 right there. So now let's look at this thermometer square. Or let's look at this whole thermometer. It ends in a 5 or a 7. We figured that through process of elimination, etc., etc. And now we're saying this square could be a 6. Or 6 could go in the square. 7 could go in the square. But could 7 go in here anymore? Well, no, because we would have to grow to 8 or 9, which we don't have space to do. We can get rid of 7 here. And now if we get rid of 7 there, all of a sudden we get a 7 right there. Which also gives us a 6. Yep, that cleared up some space. And now we get a 6 as well. And now this square has to be greater than 6. That means it's 7. We can cross out this 7 here because they share a box and column. That's a 5. That's left over. 1, 9 split. Row is missing a 1 and 9 still. We have a 9 down here, so this will be resolved. This row needed a 1 and a 9. We know the 1 will go here because of this 9, and the 9 will go over here. What else are we missing? 9. And the thermo puts 9 right at the bottom there. Nice and easy. Oh, and then this 9 also resolves this 1. The 9-1 split. That's our 1. Cross out that 1 down here. And this is a 1 as well. And now we actually get a 1 over here. We had a 1 in one of these two squares based on the solid ones. But based on this 1-6 split, we know this column is covered. This column is covered. This column is covered. Row, row. This box needs a 1. It'll go in the top left here. What else we got? We should be able to get more 9s, probably, right? Yeah, we have a 9 over here, 9 over here. 9's not going to go in the thermometer in this box. Well, actually, just with this 9 alone, we can see boom, boom. That's a 9. And then this 9 will give us our 9 in the middle here. 9, 9. That's our 9 up there. Zoom, zoom, zoom. 9 in one of those two. And we already knew there's a 9 in one of these two. So these two 9s are staring at each other. But otherwise we found all of the other 9s. This row is missing 3. 1, 2, 3, 4. 3 and 5. We have a 3 up here. So that's our 5. That's our 3. We resolve those out. And now what else? This row is missing 3 numbers. Most of them are on a thermometer, so it might be easy. 1, 2, missing 3, 4, and 5. Well, I guess those are all possible on the thermometers. But we already have a 4 in this box, so we can cross out that 4. And then what is the square possible? We're missing 3, 4, 5 in the box. Well, we know it's not 4. There's a 4 right there. We know it's not 5 because there's, well, multiple reasons, I guess. There's a 5 up here. And also, if we put a 5 here, There's no space on the thermometer. This would have to be 5.5. Nah. Smaller than 6, greater than 5. Too far apart. So this is our 3. Cross those out. That gives us a 3 in this box. So what's the last two numbers missing in this box? 2 and 1, 2, 3, 4. 2 and 5. So we have a 2, 5 cross split. I don't know. Whatever you want to call it. This 5 is not too obvious. It has to do with, technically it's an X-wing scenario. It has to do with the idea that if we tried putting a 5, so we know this 5's here in this row. So this row's covered. And then it looks like there's 4 possible spots for 5. But if we tried putting 5 over here, we cross out 2 5s at the same time. And then we're stuck with 2 2s. Or we're stuck with 2 5s in the same column. Either way, there's many ways. All we know is 2 5 cannot go in this column. We've had a similar similar situation like that earlier in the puzzle. Zoom, we get a 5 down here, and so these 5s are mirrored by these 2 5s essentially. Here we have a 3 down here. Resolves this 3-4 split. That's our 4. That's our 3. And then, oh yeah, here we go. 3 is on the thermometer, so this number has to be less than 3 due to thermometer rules. That's our 2. That's our 5. That's our 5, and that's our 2. We can resolve that split with that info. I guess I just start finishing out rows and columns and stuff. Probably. I mean, this column is missing 3 numbers, 4, 5, and 1, 2, 3, 4, 5, and 6. We can cross out 5 up here. That's it for now. What about this column? This column is missing 4, 5, and 1, 2, 3. Missing 3. So we can look at this 3. Bam. And then, sure enough, this is 3, 3, 3. That gives us our 3 right there. 3, 3, 3, 3. That gives us a 3 down here. 1, 1, 1. That's a 1. 9 is, no, this pen mark is cluing me in that we found 9. Sorry, pencil mark. Pencil. 9, 9. Sure enough, this is our 9. And then that crosses out this 9, which based on these pencil marks, it looks like we found another 9. And sure enough, with the old discount double check, that's a 9 right there. 2, 2, it's a 2. 2, 2, 2, that's a 2. We're in cleanup phase essentially. This 1 crosses out that 1. That's a 6. That's a 4. And that's a 7. This 7 will jump down here then, and so will this 7. This 7's been here for a while, hasn't it? So we could have resolved this a long time ago. That's a 4. This 4 resolves this 5-6 split. That's our 5. That's our 6. This 5 jumps down here. This 4 also jumps down here. That's our 5. That's our 4. Zoom. That's a 5. Finish the row with a 1. Finish the box with a 6. Finish the puzzle. Oh wow. I didn't notice we're only 1 square away. This is a 1, 2, 3, 4, 5, 6, 7. That's a 7. Bam. How many Sudoku thermos was that? 2? 2 out of 15? This puzzle looks kind of interesting, but you know what I'm really feeling right now? I'm really feeling some killer Sudokus. I'm feeling bloodthirsty. Do I have those? Oh yeah, I can load those up real quick. Bum, bum. Why isn't it opening? Let's go. I'll replace my watch battery. Ate a Cinnabon. Can't kill any more time. Let's go. There it is. Okay. Jump right into it. Oh, my eyes. Ah! Alright, let's close these rolls out. Let me add a new roll. Copy. Paste duplicate. Properties. We'll make it visible. Rename. Killer Sudoku. Properties, classic rules, sometimes negative space. is more. Is more. Is as important as the areas inside the cages Make this a different color than white. Let's make the blue. Maybe a light purple. No, not light purple. I like the blue the most. This isn't a killer, is it? I thought it was a sandwich or whatever. No, this is a killer. Sandwich was the numbers on the outside. They weren't very fun, so I stopped doing them. It would show like, it would show numbers on the outside, and that meant the addition of the numbers between 1 and 9 in the column, and or they had numbers on the left side for the row. They were pretty boring, pretty, you know, hardly Sudokus. They were closer to that pick cross stuff, you know, in execution. Let me reset my timer because I've been writing the rules up. But let's look at this puzzle now. 1-2 split right there. That means we know none of these cages can have 1 or 2 in them because we know we have a 2 and a 1 up here somewhere. So this cage, here's our possible solutions. Let's cross out the ones with 1 and 2 in them. This cage could have a 1, like we could have 1, 5, 9, and the 1 will be exiled on the outside over here. So can't do the same thing over here. But what does this tell us though? This tells us this is 3, and then either 4, 7, or 5, 6. It's not too bad. I was gonna say that tells us that there's not a 3 in here, but there never was a 3. And same thing up here. We know there's not a 1, 2 because the row is shared. What do we know though? We know this adds up to 24. Click the 22 box again. Yeah, so this is either 5, 8, 9 or 6, 7, 9. That actually means we know there's a 9 in that box somewhere. Although, or in this cage rather. There's a 9 in this cage. And the 9 can be either in this left box or this right box. We don't know yet. And the 14. In row 2. It would be the same technically. Because they're both 3. Well, I mean, besides the crossouts. They're both 3 big with a sum being 14. But now remember on the last time we were doing these, I was like, how do we even do this? And the answer was negative space, you know? That was your answer. So it's not 3, 5, 6. 3, 5, 6. Oh, that's true, yeah. Yeah, so this is either 5, 8, 9, which would cross out the 5 here, or it's 6, 7, 9, which would cross out the 6. That means we know help. Alright, I'm trying to use my shortcut to get rid of all the pencil marks. But there we go. Okay. 3, 4, 7. Once we know this is 3, 4, 7, we can actually ping pong it back here. This one doesn't have the 7 in it. So this is 5, 8, 9. That means this row is missing only 3 numbers. It's missing 1, 2, 3, 4, 5, 1, 2, 6. Okay. This square can't have a 6 in it because this even though this is kind of split up, it's split up such that it shares the same boxes. So we can't have the 6. We also couldn't have 1, 2, but we already couldn't have 1, 2. 5, 8, 9. So we're gonna have a situation where the 9s are like, you know, mirroring each other. And the 5s and or 8s will also be mirroring each other. Does that rule any number out in particular? Does it rule out 4, 8, 9? Does it rule out 5, 7, 9? I don't think so. It couldn't. if we could rule one out with some sort of logic, we could rule the other one out just as easily, which means we can rule neither out. Anything we can rule out over here? We know it's a 9. Yeah, we do know there's a 9 up here. If we do 21 plus 3, this is the white space. This is everything that is given to us. Row 3 has a top right now, has a 9. Row 3. Oh, yeah, you mean down here. Yeah. But yeah, no, so let's add up this. 21 plus 3 is 21. So what's 21 across 4 squares? 21 across 4 squares is a lot of options. Alright, forget about that. If it was limited though, that'd be important. Like down here it might be limited. 14 plus 15 is 16. So then what's 16 across 3 squares? 16 across 3. And because of this square, we know it doesn't have 3, 4, or 7 in the answer. You can roll one a lot. Yeah. Oh, and also 1, 2. So it doesn't have a 1 or 2 in the answer, and it doesn't have 3, 4, 7. Oh, actually, no. Could it? Oh, yeah, it could. Sorry, I'm getting ahead of myself. Because if it had a 3, we would just put the 3 over here. But it can't be exactly 3, 4, 7. Well, specifically exactly 1, 2, 3, 4, 7. So what's 1, 2, that's a 6, no. 8, no. 1, 2, 3, 4, 7, that has a 5. 1, 2. Yeah, no, we can't rule out any of these. Well, based on this square. 15 boxes solutions are yeah, let's limit this box down. We can cross them out because we can cross out if it has a 1, 2, the same thing. If it has 1, 2, 3, 4, 7, if it has 2 of the above, it could have 1 of the above, like 1, 5, 9. We could do 1, 5, 9. But what if it had 2 of the above? What if it had 2, 4? Well, we'd hide the 2 over here because 2 can't be in this box. Where would we put the 4? We would try to put the 4 in there, but then that causes too many conflicts there. So it can't have 2 of the above. 1, 2, 3, 4, 7. 2, 4, get them out. 2, 7, no. 3, 4, no. 3, 7, no. That's fine, that's fine. Yeah, the rest of these are fine. So it's one of these 4 answers. 1, 2, 3, 4, 7. Yeah. And 5, 8, 9. This box can't have 2 of the above. 5, 8, 9. That's a 5, 8. And that's it. 1 cross out there. You can take the 9s out. Oh yeah, because we have a 9 over here. 9, and 9. And because we knew this was like a mirror situation. Take the 9s out. So now that leaves us with 1, 2, 3, 4, 5. 5 solutions. A lot of mid-range numbers. One, 2, 1, 2. Does it have to have a... No, it doesn't have to have a 1. Because this is split up here. I'm ready to... 4, 8, 5, 7. I'm ready to look at like a different row. Because we can do the same. We can do what we did up here. Like down here a little bit probably. We know there's a 9 in this row. That means we know there's not a 9 in this box. This all adds up to... Oh no, we can't do that. Well, we can do something, right? This adds up to 35. So then these 4 boxes add up to 10. So we're adding up to 10 across 4 digits. 1, 2, 3, 4. There we go. Bam. Because then this 10 plus 20 plus 15 will equal the 45 for the whole box, 1 through 9. So now this cage, this 15 cage, needs 2 of the above. 1, 2, 3, 4. 1, 6, 8, no. 2, 5, 8, no. 2, 6, 7, just the 2, no. 3, 4, yes. 3, 5, no. 4, 5, no. So we know this cage is actually 3, 4, 8. Cross out a 3, 4 over here. But not necessarily down here. We could do 4, 4, 3, 8, something like that. So now we cross out 3, 4, 8 over here, cross out that 8. That gives us a hard 6, 7, 9 split. Can we remove the 1s? We can remove this 1, yeah, because we have a 1 down here for sure. That actually might... Yeah, that gives us the 1 in here, because we look at the additions here. 1's just too small to go into 20. 1's also just too small to go into 15 across 2 squares. So that's a 1 right there. Cross out a 1 up there. We should be able to figure out these two numbers. 6, 7, 9 split, 3, 4, 8 split. So what's missing? 2, 3, 4, 2, 5. Okay. This box can't have 2 of the following. 6, 7, 9. That has 6, 7. That's it. There might be a few more we can get rid of. Like... maybe. I don't know. I'm not going to explore that right now. There's probably more we can explore over here. Or here. 7, 8. If this was 7, 8, then we know the 8 would go here. Yeah, this is what happens when you cross a math god with a Sudoku god. It just happens. Oh, speaking of which, we did this trick over here where we added up 35 and found the outside space was adding up to 10. Can we do something similar up here? 28. It's probably not as likely. These 4 squares, so this adds up to, what was it, 17. So everything except for those adds up to 28. 28 across 4 digits. Hey, that's not too shabby, you know? It only gave us 2 solutions. I guess 28's a pretty big number, so you gotta have big numbers that add up to it. And now, yeah, exactly, not the top one. We can cross out the top one because we know this middle box, this middle cage, was our 3, 4, 7 cage. So we're not gonna have 4, 7 on the outside. We're gonna have 5, 6, 8, 9. We know the 9 doesn't go up there. Because we know a 9's already in this row up here somewhere. And then let's look at the solutions for 15. This was our possible solution list, and now we know it must include 2 of the following: 5, 6, 8, 9. Looks like all of those are possible still. 5, 9, 6, 8, 5, 8, 5, 6. Wait, so that told us nothing. Oh, that looked cool what I just did, but we could have just 1, 2, 3, 4, 7. We could have just done that by hand. What's the last 4 numbers in the box? 5, 6, 8, 9. That's okay though. 5, 6, 8, 9. 5, 9, 6, 8, 5, 8, 5, 6. Okay. It looked cool though. That's all that matters. 1, 5, 2, 4. No. Can we figure out this cage a little bit? It can't have 2 of the following. 3, 4, 8. No, wait, can it? No, it couldn't. If I put a 3 here, I could hide the 3 over here, but as soon as I have both a 3 and a 4, I can't hide both the 3 and the 4. There's going to be a conflict in the box. So 3, 8, 9, that's a double share. We can cross that out. 4, 7, 9 only shares the 4. We can hide the 4. 5, 6, 9. No conflicts. 5, 7, 8. We can hide the 8. Okay. What about down here? 7, 8. 6, 9. We can cross out this 4, 7, 9. Can we? Yeah. Because if we have 4, 7, 9. Oh yeah, and then might notice that too. 4, 7, 9. That would cross out 6, 9 in this cage and 7, 8. The box would be too restricted. So we know this is not 4, 7, 9. And once we cross out 4, 7, 9, now we know that there's for sure a 5 in here because our choices are 5, 6, 9, 5, 7, 8. That means we know there's for sure not a 5 across the way because it shares a row. So let's cross out those 5 solutions. Boom, 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 boom. That leaves 3 solutions there. Not 1, 6, 8. 1, 6, 8. Is that a double cross out? That is double cross out. So if we have a 6, 8, we eliminate 5, 6, 9, and we eliminate 5, 7, 8 at the same time, leaving no solution for this cage. That gives us a 4 for sure, somewhere in there. And then either 2, 9 or 3, 8. 2. So 4. I don't think we could have 2, 4, 9. Look at how if I tried putting in 2, 4, 9, we know there's a 2 up here for sure, so I'd have to put 2 over here. Oh yeah, we can pull it off. Then we put 9 over here, 4 over here. Okay. There's this. We have to put the 9 over here because we know there's a 9 up here for sure. 4. Okay. 7, 8, 6, 9. Oh yeah, so these are just like flip-flopping. One is a 6, 9, 7, 8. One is 5, 6, 9, 5, 7, 8. Isn't that just 2 bottom left? Yes. Yes, it is. These can't be 2 based on their cage. These never have a 2 in it. This never has a 2 in it. There we go. That's a 2. And now we can eliminate 2 from this solution. This becomes a 1, 3, 4 split. This 4 these 4s are fighting for some real estate, aren't they? I mean, this can't be 4, can it? Not 3, 4, 8. What do you mean? Oh, yeah. Here. 3, 4. I guess it would be 8, 3, 4, 3, 4, 1. But no, this can't be a 4 because we know there needs to be 3 4s in this bottom area. And the only 4 for this box is in here. So we know that one of these two is going to be a 4. That means that's not going to be a 4. It's a 3 or an 8. Does that help us at all? Well, the same with these 9s are crisscrossed. These 4s are going to be crisscrossed. They're in the same boat. 2, 4, 9. We do know there has to be a 2 up here somewhere. I mean, it leans me towards 2, 4, 9, but is it a lock? Two. Probably not, right? I think we can find this number here. Maybe not. 6, 7, 9. What's these 3? 6, 7, 9. 2, 9, 3, 8. One. Should we keep looking at this section? 5, 6, 9, 5, 7, 8. 2, 4, 9, 3, 4, 8. What's 10 across 3 digits? Not 2, 3, 5, because 2 of the above, 2, 5 are being split up. That means there's a 1 here for sure. There's a 1 in one of those 3. I guess I knew that. Did I know that? Does that help me? That doesn't help me. I technically knew that. Two, 7, 3, 6, 4, 5. So the square 1, 7, 2. This square could be 2, could be 1. Could be 3. Oh wait, no, 136. Dear Steven. Oh, is it? Am I getting fan mail? This can't be 136 because we have a 6 locked up here. Oh my god. Alright, I just got some fan mail in the mail here. It says, Dear Steven, word of advice, don't play Dota. Move on to a next game, you and that warlock. Or if you do decide to play Dota, there are builds to follow that actually win games and not get carried in your games. Regards, Dr. Wams. Alright, thank you, Dr. Wams, for the word of advice. I will never play Dota again. I will now only play Sudoku and Rayman 2 for the N64. Well, actually, more specifically, the Rayman 2 remake on the 3DS launch title. Nobody told me it was a Rayman 2 remake. They just called it Rayman 3D. And then they sold it as just Rayman 3D, and I buy the game because it's the only game that came out with the 3DS. And I'm like, wait a second, what the fuck is this? I've already played this game. It's Rayman 2. Thank you for the fan mail. Keep it coming. 145. Okay, so not 136, not 235. So it's either 27 or 45. 2745. Can I fit that in? 1, 4, 5, 4, 4. No, I can't fit 4 in. We know there's a 4 in here. So we know it's 127 then. Because this, we are locked on, we already locked in a 4 in this cage. Because it's either 249 or 348. That means it's not 145, not 235, because the 235, two squares share the 2-5 split. So if we try to do 235, we can do like 3, and then if two, we don't have enough space to completely avoid a 2-5 conflict. So not 235, 136 is a no-go because there's a 6 guaranteed up here. Is that okay? That might be okay actually. Because if we put a 6 up here, it would just be 6 over here. 6, 1, 3. Alright, well. So it's either 127 or 136. Did we... One, 2, 7, 3, 6. One, 2, 7, 2, 7, 1. This might be okay if this adds up to 22 by itself. 22 minus 45 is what? 33. 2, 2, 33. 33 across 6 digits. Is that restricted? I mean, that's a pretty big number. Or no, it's not restricted. It's not too restricted. Ow. Do we just keep going? Ten over 4 squares for row 8. This is 3 squares, right? It was 10 over 3 squares. Yeah, that's what I was looking at. So we could do 10 over 3 squares. And then what can we rule out? We ruled out 235 because if we try to put 235 in these 3 blank spaces, we're going to force a 2-5 conflict. It's the rule of doubles or whatever. the double sharing rule. Alright, thanks. That light doesn't work right now. It went out like a couple days ago. Boy's got his pizza. What else are we looking at? It can't be 1, 4, 5 because we knew a 4 is in this cage. So I gets rid of the 4. And then I thought it was 1, 2, 7, but I realized 1, 3, 6 is still possible. I think. If I put a 3 over there. I mean, 3 is like a highly contested number, but it's gotta go somewhere, right? Doesn't go here. Oh, well, look at this. We know 3 doesn't go down here or here, so we know 3 has to go up here somewhere. That means that cage won't have a 3 in it. Or it doesn't, right? Because you have to fight 2 squares over the 8 box. Well, I just found an 8, so let's look at this. Because we can't put the 3 in here. Because otherwise this box has nowhere for a 3 to go. So that's an 8. 3, 4 split. And now where's that put us? Like where's 8 go in this box? We already have one. Okay. Where does 8 go? I mean, does that change anything? 3, 4. Or it doesn't, right? Because you have to fight 2 squares in the 8 box. Okay, 8 box. Fight 2 squares. 1, 3, 4. And then what was my solution combinations? So 1, 3, 4. If I do, let's say I put the let me think about if I can arrange this. 6 over here. 1, 1, 3, 3, 4. Yeah, the rule of doubles doesn't quite apply because we're like too far apart. Yeah, it barely makes it. And the double thing kind of happens when there's a cage whose entire solution is in one box, and that's partially sharing another cage. So like there's 2 squares contested by 2 squares, and then 1 exile square. In this case, they both have an exile square, so they just couldn't be like the same exact answer. 1, 2, 7. So 7 would have to go over here. I think I already looked at this. 7 would have to go over here because the 7 is locked in up here. 2 would have to go over here because the 2 is up here, and then 1 can go there. And then 1, 3, 4, 4. Yeah, so it all works out, I think. 3, 4. Or does it? Then we have 3, 4 over here. 3, 4, 8. Well, maybe for the most obscure reason, it can't be 1, 2, 7. Unless that proves something else. 1, 3, 4. Okay, I think this 8 is resolving this square bit. This 8 is limiting our exile squares. Yeah, it does. It does. So the well, the far right isn't 6 or 7. Yeah, I know. I just kind of I'm just kind of marking this off box, but like in a weird way, just so I don't have to like have the calculator up. But okay, can this be 3, 4, 8? 8. And now we know 8 will go over here somewhere. And then we just have 3, 4, 3, 4. So 1, 3, 4, 4, 3. Oh, I guess that works, doesn't it? And then what's the last solution here? 2. I think the only reason it doesn't work is when you take all 3 factors in combination. I mean, I already proved that, okay, if this was 127, there's only one possible solution. Well, 2 possible solutions, but they don't matter. You know, like the ordering doesn't matter. 2 over here, 7 over here, 1 over here, or 1 or 7, you know, either way. If that's the case, 1 has to go here. We're forced to have 3, 4. And that 3, 4, you know, it forces a conflict here. So we know that's not 127. That's 136. One, 3, 6. I wish there was a cleaner way to do that, but it looks like that's just how we got to do it. Once this is 1, 3, 6, we can cross out 3, 4, 8. This is 2, 4, 9. The 9 will go on the left because there's a 9 up here already. 2, 4 split. That crosses out that 4. We can cross out this 6 over here. Take out the 6. Yep. 1, 3 split. 2, 4 split. What's the rest of the box? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a 5, 8 split. This 5, 8 split resolves this half. 6, 9. And then I think we can get this number. Process elimination. 7. This 8 crosses out an 8 up there. I don't think it matters, but mark it before I forget. And then what is this? We should be able to figure this out. Not the one with the 6, the one with 5, 7, 8. So this is all... So this whole bottom's resolved now. Well, not resolved. This is all accurate and like pretty much a lock. Is there anything we can figure out then? Particularly like here, maybe? Probably not, right? One, 3, 4. I don't think so. (20 over 4 squares). Let's plug it in. Too many solutions. Good question though. Sometimes it's restricted. You know, you don't know until you check. Yeah, it's weird. These like... What about 19? A few less, but you can see 1, 2, 3, 4. You can see every number crop up. If you scan it real quick. 4 squares or 3? Because it's 19 across 3 here, if we added up these two. Well, I guess the opposite of 19. Because of the 6. Which row are you looking at? Is that, it'd be one of these 2 for rows. So that was the 20 across. Yeah, that was the 20 across 4. This was the 19 across 4. I'm more interested in... Have we done this one yet? Let's do 15 plus 14 is 16. 16 across 3. Is that a big deal? No, not really. There are a few crossouts though, but not enough. One, 4, 2, 3. 1, 5, 2, 4. Yeah, this puzzle's kind of weird. Yeah, row 6. This puzzle's kind of weird because it's just like 3 little mini puzzles stacked on top of each other. So far, you know, they don't really interact with each other in any meaningful way. I think this is a meaningless, but I'll do 25 across 6. It's probably gonna be every number in the book. Not too bad actually. Look at that. There's a 1 and 2 locked on the outside. 3, 4, 5, 6, 7, 8, 9. So we know the middle doesn't have 1 or 2. We already knew that. Oh, but can we do similar logic? Like, okay, if I click up here... I mean, technically we can do the 1, 2 across the whole board. You know, we know this has a 1 and 2. I guess it's not helpful, though. Oh, you know what is helpful, though? 20, 20, 20. These are all 20s. So what are these? 1 and 2. That's a 1-2 split. Because we know the rest of these can't be 1 or 2. That's pretty cool. Good idea. Terrible idea. Get rid of a couple, but still a lot of solutions. One, two. What about down here? This was 19. Across 4. Get rid of any that don't have 1 or 2. Not very helpful. The answer for this 6 box is directly influenced and or influences this 1-2 split. This 1-2 split directly influences this 2-5 split, which influences this 1-6 split. So I guess there are some vertical influences going on, but maybe we gotta keep exploring to find them some more. One, 2, 4, 5, 3, 4, 5, 6, 7, 8, 9. No. 1, 2, 3, 4, 5, 7, 9. I mean, look how... Oh, I don't know if I was... Am I muted? My mouse not moving. There we go. Okay. Look at how much we were able to figure out about the bottom. Shouldn't we be able to figure out almost that much stuff out about the top? Especially that we have like these two as a lock. This is like... We can resolve this box a lot better than we think we can. I mean, like 159. Where's the 1 go? This 1 crossing out this 1 all of a sudden forces a 1 in this row right here. So now we can get rid of the 1 solutions here. The 1's not going in this box because the 1, 2 here, and the 1's not going in this box, and then in this box because of the 1 here. As a matter of fact, the 1, 2. 1, 2. I don't know. We can still have a 2. We can have 2, 2, 5, 8, and so on. But yeah, now we get the 9 because we cross out the solution with 9. So that's a 9. Gives a 9 down there. And this is a 2 or a 4. Doesn't matter which one yet. 5, 6, 8. Well, we can cross out 5 over here now because we know there's a 5 in one of these two. Oh, no, we don't. Do we? Yeah, we do. 2, 5, 8, 2. So we can cross out 5 up here. Only 2 solutions. Did I do that right? I mean, what was the crossouts? We got rid of the 1s. We got rid of the 9 a long time ago. And then this had like 3 and 7, that had 2 and 7. Yeah, okay, that all makes sense. So 2, 5, 8, 4, 5, 6. This does not have 5, we just got rid of those 5s. So what can this be? Well, we just found the 9 from getting the 1 info. Well, right. Or which 9? Nine. 3, 4, 7. I mean, this is 1, 2, 3, 4, 7, 5, 6, 8 split. Okay, well, you know what? Let's just look at this negative space because we know it has a 9 now. For sure. So, 16 less than 45. Across 3 digits. Has to have a 9. Only 2 possible solutions. We know it doesn't have the 1. I can't have the 1, right? Yeah, the 1 would be in here. So that's 3, 4, 9. This 3, 4 crosses out that 4. Means this is 2, 5, 8. That gives us 6 up here. Stop me if I've screwed up. We get 2 up here. This 2 resolves some stuff. Nothing that will really have a huge impact, but it gives us a couple of splits. Well, it will have a huge impact, but not only because now I can start doing this. 2, 4. 1, 4. 4, 1. What is this square now? Or what is this cage now? This cage does not have a 2 in it. does not have a 3 or 4 in it. So that's 167. One will go there. And this row makes sense. There's no done goofs staring at us. 1-6 split resolves this as a 2. Wait, what? What did I erase? Oh, I erased the 6 for some reason. 1-6 split resolves that as 2. What's up, Alex? We're just doing a couple killers right now. Did I find a 2? I think I did find a 2. 2, 2. Erase those 2 cancel marks. Oh, that was for this whole row, these 2s. But no, we know this 2, 4 is down here now. So we can cross out these 2s. And that's covered. That's covered. Get a 2 right there. We can do a couple crossouts here. Get rid of the solutions with 4. Oh, this 1. Yeah, we just hit the breakthrough stage. So we're going fast right now. But it wasn't too long ago we were staring at, you know, not much. We found this, we logic through this one, this cage, and found a bunch of stuff off that 2. There's a huge 2. And it just kind of, you know, exploded in both directions. Okay, we're up to date. So what can we cross out still? One. We have 2 1s now. We can cross out all these 1s. That's a 1 there. This one resolves this 3-1 split. That's our 3. That's our 1 for the other part of the split. This 3 will jump back here. This is our 6. We know there's a 6 in one of these 2. This 6 will cross out a 6 down here. Doesn't matter too much. Cross out a few 1 pencil marks. We don't need those anymore. This is the world's longest song. What song is this? Grassland Grove from Donkey Kong. We can cross out this 4. We have a 2-4 split. That'll cover that 4. Also, we can cross out this 2. If we tried putting a 2 up here, we would force 4, 4 down here in the same column. That's not possible, of course. So this 1-2 split goes 1 there, 2 there. This 2 will jump down here. That's our 4. That's our 2. This 2 will keep going, cascade down. 4, 2. This 3 will jump back up here, cross out a 3 up there. And same thing with 4. 7. 3. Donkey Kong. I was I'm playing a really good puzzle game, constantly report on Sandy Parable. Ever heard of Superliminal? Don't think so. Let me, Superliminal. Oh, is that? No, it's not quite what I think it is. I saw a puzzle game that was all about just like weird logic. Like the game was just made to be, it was very simple graphics, like black and white. And you had like these weird guns that shoot blocks, and you just had to like figure your way out through them, like some maze, some very claustrophobic maze. It looks pretty cool, seeing the screenshots. Yeah, I'll go ahead and once we start branching away, you know, from just oh wait, I found a 1. Once we start branching away a little bit, you know, I gotta start bookmarking some other puzzle games. So just normal Sudoku gives us the 1 over here, and that's definitely looks like it could be cool. Came out. But yeah, witness, and then that one. Oh, we have a 6 bottom right. Yes, we do. 7. We'll jump down here. That's our 6. 7-9 split. No resolution, I don't think. 5-8, 5-8. I'm like zooming out right now, trying to see if I can find something. 4. 4, 4. This one has a 4 in it. Only one answer. That's 4, 7, 9. No, I mean, I'm not saying you're pressuring me. I'm just saying because I was looking for puzzle games for the stream. We cross out a 6 here, the pencil mark. Once we lock this as 4, 7, 9. So now we know this one has to have a 6 in it. This is 5, 6, 9. As a matter of fact, our 6 goes exactly here, right? Zoom, zoom. Yeah, that's our 6. 9 is in there for sure. That means we can get rid of that 9. This is our 5. That's our 9. Dr. Wams is saying... yeah, no, that's fine. Might give you something for the 20 block. 5-8 split in column 9. It would cross out this 5, 7, 8, that's for sure. Because if it's both 5 and 8, we would clobber this square. Right, yeah. People aggressively recommending games. 4, 7, 9. Can this square have a 9 in it? Yeah, we can exile the 9 over here. But can it have a 5 and a 9? No, it can't. Because we'd have to exile the 5 over here to hide from this 5. And we'd have to exile the 9 over there to hide from that 9. So this is 3, 8, 9. Now you have 20 over 4 with a 2 and either... Seems pretty limited. This negative space. Yeah, well now we just get this 3, 8, 9 split. We get even more info. We know that's our 5. We can resolve that too. And we can also jump up here and resolve this 8, 5. So yeah, so this negative space adds up to 20. Has 4 digits and includes a 2 and a 5. Needs both a 2 and 5. So no, 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 no. No. Yes, maybe. Maybe. No, no. So it's either 2, 4, 5, 9 or 2, 5, 6, 7. 2, 4, 5, 9. So that would be saying this is either a 4, 9 split or a 6, 7 split. Not the 9? Because 2, 8, 9. There we go, perfect. So 6, 7 split. Yeah, let me know. I mean, well, I'll probably start working through them soon, so you know. But it'll be good to have a backlog as we move forward. Definitely the witness will be the first one of any. Maybe next week. I was thinking about next week, potentially. That just forces 9 in the right box, right? Probably. Yes, it does. We have a 4-7-9 split, which means the 9 has to be exiled over there. This 9 will resolve this 7-9 split. 7-9. We can cross out some stuff here, right? Cross out that 7. I think this was solvable, right? No. This column needs a 6-7 split. So a 7 in the middle would cross out that 7. So that's our 6, that's our 7, that's our 6. Yep, Dr. Baum's found the same thing. And yeah, definitely. I've heard nothing but good things about the witness. So I am looking forward to it quite a bit. Oh, what do we have here? 3-4 split. That can't be a 3. A 3 here would force 4-4. Of course, we know 2 4s in the same column, not legal. That's our 8. That's our 3. We can resolve this 3-4 split. 4-3, and then 4-3. For 9 will give us a 7 right here, a 9 right here, and a 4 right there. 3-8 split in column 7, good to know. And then let's check for resolution. Nah. This is a 5-9 split here to finish this column. What is this song? Ooh. Five and 9. There's a few we can do like some crossouts around. Only 1 in column 5 and 6. Column 5 and 6. Oh yeah. 1, 2, 3, 4, 5, 6, 7. Missing an 8. Let's lock in that 8. And then 1, 2, 3. I'm thinking it's a 9, right? No, we have a 9. 4, 5, 6, 8, 9. That's a 7. So this solution up here is a 7 now. We know it's 5, 7, 9. So this is a 5-9 split, with 9 resolving this immediately. That's our 5, that's our 9, that's our 5, that's our 8. And we can finish this cage off with 9. 5 plus 8 plus 9 equals 22. I'm sure. At least my calculamatron's telling me that. This 9 will jump all the way down here now. Do a double resolve. That's our 6. That's our 9. Ping pong back. That's our 7. That's our 6. This row looks this column looks solvable. Yeah, 5, 8 gives us 7. 3, 4 split. 4 there. That's our 3. That's our 4. Cage finishes with a 3. Row. This 8-3 split is resolved. 3, 8. And then row 1, 2, 3, 4 needs a 5. 5. Cross out there. A cross out there. And a cross out here. So that's a 8 right there and a 5 right there. We're done with the puzzle. There we go. We only have 4 squares to resolve. 1, 2, 3, 4, 5, 6, 7, 8. 4, 8 split, and 1, 2, 3, 4, 5, 6, 3, 7 split. Let's start with the 3. This is our 7. That's our 3. And then 8 up here. That's our 4. And freezing on the answer. Don't know. 66 minutes. And then bam. That one was pretty. So 66 minutes, I would classify that as a long solution, you know? But it wasn't very painful. Some of these are painful. 112. Ouch. 85. Very painful. 94. 107. Right in the middle. 66. With pizza breaks in between. I was, you know. I was about to say, I was going to say the next puzzle looks very similar. I was looking at the same puzzle. Okay, where are we? Puzzle 11. Am I going to do another killer Sudoku? Oh wow, that's a cool square. 45. Just straight up. Who wrote this one? Bastian Vile James. No. I trust Richard Stolk. It took us a long time for his first one, but then we were able to do his next one pretty quickly. The next one, no trickery. No trickery, pretty easy. And so that's who I was looking for. But no, just Bastian, I don't know who that is. Do I tackle this? Yeah. We got time. Yeah, I don't know. It's got to take a lot to design these. 1, 2. Is that this guy? Oh no. Lots of 5s. I do see lots of 5s, yep. And then like this 1, 2 hard split is gonna like meow. It's gonna lock this to 1, 2 over here, and then 4, 3 over here. Whatever the resolution is, they'll mirror each other. Let me actually. I need to go get a drink. I'm getting dry. So let's move that real quick. Visible, unlock, slide it to the top. Did I do one earlier? Yeah, there he is, number 7. He was a long one too, 85. Let me think if this one was. This is mouthful. I think I remember that one. Yeah. So yeah, I'm gonna go get a drink. I don't know if staring at this is very helpful. It kind of helps to have the calculator, but obviously you can't do that on your own. But go ahead and think about clues. Here, this will help you. There's a 1-3 split here, and that gives us a 4, 2, 1, 3 split there. All right. Be right back. Alright, we're back, boys. A Fistomuffles theorem. It proves that 2x2 boxes in each of the 4 corners has the same 16 digits as the 5x5 ring. Oh yeah, I need to turn the music down again. I turned it up while I left. I have seen that, I believe. It's very familiar. So it was, so 4 corners, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 13, 14, 15, 16. 16. And then what's the 5x5 ring? This ring. Yeah, I think I remember seeing a, I don't know if the puzzle relied on that logic, or if it was just like a puzzle. I think I saw a video showing off that theorem. Whether or not there was a puzzle that required that theorem, I don't know. Although that would be, okay. 2x2 boxes in the 4 corners. That could be interesting if there's like, if you have all of the edges, you know? Because some of the puzzles, you end up with like the outside but not the inside. And you could kind of like figure out, you know, I don't know. Your 4 boxes a little screwy. Yeah, I think I screwied it when I was unmuting or whatever. One, 3, 1, 2. So where do I start with this one? $22, $23. So what's 23? 22 less than 45. I don't predict this is going to be very restricted. 22 across 4 digits. Not at all. What about 27? It's not too bad. We know there's a 9 in here for sure. And we know there's not a 1 or a 2. So there's a 1 and 2 in here for sure. 3, 4, 5, 6, 7, 8, 9. Cross out the 1, 2s. Well, we already did that. I mean, there's no answers anyways. 14 bucks doesn't have a 1. Oh, that's good. That's huge info. So we can cross out those 1s and the 3s. So we know this has a 2. I didn't even, it hadn't occurred to me that this was just a given 1, 3. I didn't think about that. So 1, 5, 2, 4. Yeah, that's the what we're looking for. 2, 4, 8, 2, 5, 7. 2, 4, 8, 2, 5, 7. And then what was this again? This was 2, 4, 8, 2, 5, 7, 3, 4, 8, 5, 7. I don't think I can figure out anything here. Based on the other cages in the box. With this plus sign, doesn't this give us what are the 14 solutions for 3? 248257. So 1, 2, 3, 4, 5, 6, 7, 9. Is there anything to know about that? Pairing for the other 4? Monument Valley. Game. Is that like a navigation I guess would you call that like a navigation puzzle? I don't know. Like there's those old games where you have to like you're playing as like a box and you have to like roll around, one of those. Pairing for the other 4. Cross out 4, 5 or 4, 7 or 5, 8. Can we though with the bend? Cross out 4, 5. Oh, I see what you mean. So if it was 5, 7, or no, if it's 5, 8. I don't know if we have one of those, do we? 4, 5. Doesn't look like we do. But we cross out the 3. Oh, that's actually huge. We could have crossed out the 3 because we have the 1-3 split. So then let's look at, not only are we guaranteed a 9, we're guaranteed a 6. Four, 8, 5, 7. 4, 8, 5, 7. Oh yeah, so they're sharing what? They got the split going. 4, 8, 5, 7, 4, 8, 5, 7. Okay, yeah. Some of those navigation puzzle games get like too big brain on me. When you have to like plan a route throughout the whole level. For the cross, the tips are 1, 2, 3, 4. One, 2, 3, 4. Oh yeah, likewise, we have 1, 2, 3, 4 here. And that's how you figure that out. So this is 5, 6, 7, 8, 9. I mean, that's good info. I mean, that's huge info. I mean, look at this square by itself. It's already a 3, 4 split because we have the 1, 2 staring at it. 1, 2, 3, 4. Same thing over here, 1, 3. That's a 2, 4 split. Those are some weird splits too. I mean, I guess they're not weird by themselves, but they're like in some strange locations. 2, 4. 3, 4. There's a lot of symmetry going on here. So like I keep thinking I can find something because I found it on the other side, but not quite. Well, oh well, no, okay, now we have a 3, 4 split, so we can cross out that 2, 4 over here, because it's not gonna have a 4. We put a 4 here. All of a sudden we're forced double 3s. So this is a 1, 5 split. That resolves this to 3, that to 1. We can do the same thing down here. This won't have 4, this won't have 2. That's a 1, 6 split. For the 8 box in the bottom left is not 2, 6. Could have 2. Could it? If I put a 2, 5, then I'm forced to have 4, 4. If it's in the top part of the bend. Oh wait, you're talking about the 8 still. Okay. Which one are you talking about? The 8 in the bottom left is not 2, 6. Right. Could have 2. Oh, was that a rescending? You're right, I was looking at the bend logic. Okay, yeah. Okay. So yeah, this is a 1-6 split. That means this cannot be 1-7. We could hide the one up here. Oh wait, no. That means it could be 1-7. Alright, well. I talked myself out of it, don't worry. The 8 box doesn't have a 2. Let's think about that. From the 14. Well, if I have 2, 6, couldn't I have... Well, I guess it'd have to be 6, 2. Couldn't I put the 2 up here? And then it'd be 2, 4, 8. No, it's fine. I mean, it gets confusing. I was about to do the same thing. Like I was about to cross out 2, 6 and 1, 6 and 1, 7 because of the 1, 6. What was our calculatrons here? Doesn't have 3. So then it was 4, 6, 8, 9 or 5, 6, 7, 9. Well, if it does have a 4, it's in the middle. And then 5, 7. 5, 7 could go either way. Five, 7. I felt like I was about to find something. Like, what was I doing a second ago? I found that 1, 6. No, I guess okay, I guess this is where we're at. 1, 6. Two, 3, 4, 1. This might be irrelevant info. That one of these two is a 1. What is 20 over 3? Check it out. Those. Where are we seeing 20? Oh, I guess in the top right. Or is there another negative space we're looking at? it might not be super relevant, but if we add up like 1, 2, this is a 3, 4, 5, 6, 7, 8, 9. It's a thick split, but you know, it is a split. 1, 2, 3, 4, 5. So 2, 6, 7, 8, 9. And we can do some crossouts. We can cross out a 2 over here, a 3 over here. Nothing too crazy, but 2, 3, 1, 4. 1, 1. I mean, this square in particular, much more restricted than the square right above it. This square in particular, well, actually no, that's not true, because if this square is restricted, the square above it naturally becomes restricted. So this bottom square is 7, 2, or 3 and 5, which means this top square is 1, 6, or 3 and 5. Let's pencil those in, I guess. I don't know. It becomes real sloppy real fast. 3, 5. I'll just pen them in. I'm also wondering if there's, I mean, is there any synergy, or not synergy, like force symmetry between like these two endpoints? Like this is 3, 4, 2, 4. Does that imply anything about these other halves? I'm not sure. Right, like if we put a 2 here, forces a 1, 4, 3. So let's think about this. A 2 here would force 1, 4. That's a 3 then. That's a 3. And then 3, 2, 4. And then we have 2, 3. Okay. So essentially, a 2 here means that it's paired with a 3. 1, 4. And then there's a conflict. So could this be a 3 then? A 3 here would force 2. 1, 2, 4, 3, 4, 2. Yeah, no conflict on the 3 on the right side. So just the 2 here. That means we could have a 3, 2, 3, 2. Or as far as I know, a 1, 4 in either. No 3. One, 4. Yeah, it is pointing out a lot of stuff, isn't it? A 1 here. I was looking at 1, 4. But yeah, let's look at 1 here. 1 here would force 2, 3, which forces 4, 1. Oh, and then there you go. We already can't have that. So this can't be a 1. Could this be a 4? A 4 here forces a 1. That's a 3, 2. That's a 1, 4. That becomes a 2, 3, 4. 2. That'd be a 3, and that'd be a 1. So that solution is possible. So we could have a 4 in the bottom. Doesn't mean we do. This could be a 4, which would make that a 1. So I don't think row 6, column 4 can be a 1 if my logic is right there. Yeah, that's the, I was trying to think if that's how that works. That was my, like, next, like, the symmetry was, like, super, like, suspicious. That it would reflect something on these squares here. 2, 3, 2, 3. Can I put... So we're saying we're suspicious that this can't be a 1. If this is a 1, then 3, 2 is forced. 1, 4 is forced. Oh, well, there you go. 3, 2. 2 forces the 1. So 3, 4, 1, 2. So let's think about this. Wow. 1, 2. If I put a 1 here, had a conflict there. Does that mean if I put a 1 here, there's a conflict? 1. Wait, did we already prove that? We already proved that. Okay. So does that mean if I put a 2 here, there's a conflict? 2, 1, 4, 3, 2, 4. Not necessarily. That's 3 breaks. 3, 4, 1, 3. Yeah, okay. Three breaks, which means that's not a 2. Because the opposite one corner is 1 or 3. Row 4 column has to be 2 or 4. 1, 3, so 2, 4. 1, 2, so 3, 4. Okay. And then And now the next question is it going to be like this on every side? So we know one of these two is still going to be a 1. Whoops, I erased that on accident. One of these two is going to be a 1 for sure because we know 1's not going to be over here. And this plus sign needs a 1. So let me think. 2, 3. Three, 2. Hmm. 1. So row 5, column 3, 4, 5, 6, 7 have to equal column 5, row 1. Row 5. 1, 2, 4, 5, 6, 7 have to equal column 5, row 1, 2, 8, 9. Right, so yeah, so these 5, and then there's 4 left over, and these are the same 4 left over. And then these 5, there's 4 left over, which are the same 4 left over. Does that mean... Well, so I knew there was a 1 in one of these two, right? No, I guess their 1 could be up here? Five. So this 5 adds up to these, and then these 5 have these. Two, 4. Five, 2, and 2. 3, 4, 3, 4. 2, 4, 2, 4. So what's the equivalent? 1, 2, 1, 3. Like, I don't know if this is the case. I'm trying to prove that. Maybe I'm trying too hard. Let's say I plugged in a 4 here. That force 2, 4, 1, 2, 3. 4, 1, 2, 3, 4. Whoops. Is that actually all forced? If I put in a 4 here, 2, 4, 1, 2, 3. This is all forced. That's a force 4. Yeah, so this can't be a 4. I have a feeling it's gonna, and now let's try the same thing with 2. 2, 4, 2, 3, 1, 4, 3. Wait, why does 2 work? 2, 3. I think row 4, column 4, and row 7, column 5 have to be opposites. So row 4, column 4, and row 7, column 5 have to be opposites. Four and 4 means 1, 2, 3, 3, 2. Yeah, I believe it. I mean, I'm on like a similar, you know, 2 and 2. So then 4 and 1. And then there's no solution there. So these have to be opposites. This, if I plug in a 3, we get 4 there, 3 there, 2 there, 2, 4, 1, 1, 1, 4. So 3 can work. 1. I think 1 can work. 1, 3, 2. 1, 4. 3, 3, 2, 4, 2. Yeah, so the only thing I was able to rule out 4, I guess by blind luck, was the 4 up there. I thought I could rule out more than that. So, okay, so row 4, column 4, and this feller have to be opposites. True. So then these are equals, is what we're saying. Yeah. Which means these are also equals. The you know, the opposite of the cage. Well, can't we apply that same logic sideways? Because this is boom, boom. So if it was, so the same should be true for these two. If I put in a 4 here and a 4 here, it should break. 3, 2, 2, 4, 1. Oh, I'm going too far. We already have a 2, 4. So these are the same, and these are the same. Highlight the pairs. Yeah, let's highlight those. Or should they be in the... I guess the color's fine, right? Because they're different numbers. Or should I do a different color? I'll do a different color. And then technically these are also pairs. So 3, 2, so if this and this had to be the same, and this had to be the same, boom, 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 boom. So you and you have to be the same. Oh wait, I already know that. Okay. Wait. Why couldn't this be a 4? 2, 4, 1. And then that's a 2, so that's a 3, and then we're forced to have a 4. So it's because these two end up being it forces these two to be the same. But now, so that can probably go sideways again too. So this couldn't be a 4, so this couldn't match 4. Force the top right middle column 3. It's pretty good. Back to some basic Sudoku, but it's good to know. I already tested 1, 2, 3. So 4. Why did 4 not work? 4 didn't work because it forced 4, force 2, 4, 1. Was that just like a coincidence, or is that, or were we onto something? It forces 2 4s. So what about doing 4 right here? 3, 4, 1, 3, 2, 4. Yeah, this also can't be 4. I'm just kind of trial and erroring it. I'm just kind of pop, pop, punch my way through. But let's do 3, 4, 3, 2, 4, 1, 2, 4, 1, 1. Is this all 4s? I think that's all 4s, right? 3 forces 4, forces 3, paired with a 2, forces 4, forces 1, paired with a 2. These 3 force 1, 1 forces 3, 3 forces 2. Yeah, so that's all forced. So this can't be 3. And this is what I wanted. This is what I wanted a long time ago. I was going out of my way to prove this. So if this is 2, 2 forces 4, forces 2, 3, 1, 4, 3, 4, 1, 2, 3. So that's possible. Let me go back one more. And that restricts the 8 cage. Yeah, so let's jump away from the middle now. We got the 1-2 split. So this is now a 3-5 split here. Because it can't be 1-7, can't be 2-6. So now this cage, this 15 cage, doesn't have 3 or 5. See ya, see ya, see ya, see ya. All our 5s. Could it have 1-6-8? No. Because we have this 1-6 staring at it. So if we try to hide the 1 and 6 away, we can't fit them all. There's going to be a conflict there. So we get rid of the 1-6-8. That means there's a 2 in here for sure. And then either 4-9 or 6-7. And then what do we know about the outside now? We know there's a 1 on the outside for sure. But we already have a 1 on the board. That's a 1. Anything else we can find out? 2-6-7. 2-4-9. I mean, is this 1 big? Well, row 3, column 5 can't be a 2. Row 3, column 5 can't be a 2. I tried to... Did I mess up on 2? I thought I tried 2 earlier, thinking it would be the same because of the symmetry. 2, 3. Forces a 1, forces a 4, forces a 3, forces a 2, 3, 4, 1. And now we can't have the 1. Okay. That's what I like to hear. Get rid of that 2. If we can solve the middle, that's great, but this is all I wanted. I wanted this symmetry. Zoom, 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 zoom. This 1-3 now will also give us 2-5 up here. I must have either more info resolved that. Oh yeah, I think getting rid of this... Oh, that's so weird. I wonder if getting rid of this 3 was the restriction I needed. I don't know. All I know is it's worked out. 2-5 split. So let's do the same thing we did down here, up here. We can cross out anything with 2 and 5. See ya, see ya, see ya, see ya. Wouldn't want to be ya. We know there's an 8 in here for sure. Some of these take a real long time. These killer Sudokus are absolute killers. And maybe there's some logic, but I don't know. You can lock a 3 and 5 pair in box 3. Let's think about that. Oh yeah, so 3-5, 3-5. So 3-5 crosses that out. This 1-3 crosses that 3 out. Zoom, zoom. That's nice. 3-5 split. This solution now has to have a 3 or a 5, so we can cross out 4, 7, 9. That means we know for a fact a 4 goes on the outside somewhere. Oh, well, this has to be 3, 8, 9, right? Or does it? No, because the 3 could go in the middle. Okay. 3 can go in that open spot there. This 3, 4 crosses out this 4 in particular. And then what's the negative space here? So it's 23 less than 45. Let's do 23 across 4 digits. Not including 2 or 5. So we know there's a 7 and a 9 in here somewhere. Click the 20 box again. Yeah, 1 second. 1, 6, 7, 8, 9. So then the other 2 options are 1, 6, and 3, 4. Okay. 3, 8, 9. 5, 6, 9. 5, 7, 8. I think because of the bend, we can't eliminate as much as we want to. I see that's true. How did we get there? I guess we got there by this 1 5 crossing. Oh yeah, so these 5s made this, and then this 5 and this 5 means we need a 5 over here somewhere. So let's cross out that. So we get 2 4 8 over here. And then what's the contrast? So 1, it's 1 3 2 4 8. 1 2 3 4 8. So 5 6 7 9. Cross out that 5. I had more crossouts. What did I have crossed out before? The 6 down here. So 5 6 9. 5 6 9. 6 9. 5 9. And then 7s across the board. Has have a 4. 15 cage, box 7. Box 7. Yeah, it does have to have a 4. Yeah, there we go. The 2 4 line up. Cross those out. So now we know this is 2 4 9. That means the empty space is, we have 1 2 3 4 5. We need 6 7 8 here. This 6 7 8 crosses out a lot. It crosses out 7 8 there and 6 7 there. So that's a 5 9 split. Very nice, very nice. Just to double check, 1 6 7 8. 22 less than 45. I predict it will be fine. 1 6 7 8. Yep, there it is. Doesn't hurt to double check. Three 5. I don't know. Sometimes it just goes nowhere. But when we do start solving it, we have so many splits, it's just going to spiral out of control. Cage, 8 cage, box 4. Okay. Has to be 3 and 5. So 2 6. So yeah, 1 2 split means if this is 1 7, forces 2 and 2. If this is 2 6, forces 1 and 1. So 3 5. 3 5. So now we have a 3 5 split, which will resolve this 2 5. This 2 will jump down here. give us a 2 there. This 2 will jump over here, give us a 2 there. This 4-8 split now will resolve this 4-9 split. That's a 9. That's a 4. Heck yes, here we go. Alright. So then, what else we got? We got... no info there. 6, 7, 8. Cross out the 9 down here, I guess. Yeah. What did we find? We found 2, 5. We found this corner. And we found a 2 here. So what can we do with these numbers? 2, 4, 8. Cross out that 8. 3, 5, 7. 5, 7, 3, 5, 7. Unfortunately, this 2, 5 doesn't, you know, resolve this middle spiral. But what was our choices for this empty space? It was 23 less than 45, so 23 across 4 digits. We cross out anything with 2 and 5 in it. I guess we could have done that before anyways. And then we have 1, 6, 7, 9, or 3, 4, 7, 9. Well, 3, 4. Seven, 9, 1, 6, 3, 4. So no 7, 9 in the cage, the 15 cage. Yeah, did we resolve that? I think by accident we did, or on purpose. Click the 15 cage. 1, 4, 7, 9, 3, 6. Wait, what was our choices? Get rid of the 2 and the 5s. 2, 2, 2, 5, 5, 5. 1, 6, 3, 4. 1, 6, 3, 4. 1, 6, 3, 4. So they're mirroring. I didn't know if there was a locking where we were locked into one, or if they were mirroring. It looks like they're mirroring. 1, 6, 3, 4. 3, 4, 8. We can't fit 3, 4, 8 in here, can we? If we try 3, 4, 8, we have the 3 lining up and the 4 lining up. So we can hide the 4 over here, but then 3, 8. That's a no-go because of this 3 split. So that's not 3, 4, 8. That's a 1, 6, 8. Boom, boom, boom. And now we know this is 3, 4, 7, 9. There we go. And we can do some crossouts. That's not the 1. These aren't 3. That gives us a 3 right in the middle. This 3, 5 split locks out 3 over there. And 1 isn't on the right. I think I got that one right. Yeah. 1, 6, 8. 4, 7, 9. 4, 7, 9 split. We'll cross out that 7 down there. Does that give us a 4, 7, 9, 1, 2, 3, 5? So 1, 2 is a hard split. 3, 5 is a hard split. 4, 7, 9 is a hard split. That means this is a 6 or an 8. By, you know, process of elimination. I feel like this should... Well, we just found this 3. Oh, there we go. We found the 3, resolving this 5-3 split. Now we know this cage has to have a 3 in it, so this is an 8-9 split. That 8-9 will cross out that 8-9. Don't know if that matters. What does matter is that it crosses out this 8 down here. 4, 8. Whoops. 4, 8. Cross out a bunch of 8s up there. And so now all of a sudden, where does the 8 go in this cage? Only one spot. Right there. Cross out my 8s while I'm at it. Top right 4. This 4 will bounce back up here. 4, 3, 4 split. Zoom, zoom. That's a 4. This 4. We'll cross out that 4. We have a hard 1, 9 split, 8, 9 split. What's the last two numbers? 1, 2, 3, 4, 5. So 6, 7. We have a 6, 7 split there. This 6, 7 split will resolve this 7, 9. If we put a 7 here, we're forced to have 6, 6. That's a no-go. So that's our 9. And what do we got? Top right 4, we got that 2, 5 on the 7 cage top. We can cross out 3 for sure. Can we cross out 1, 6? Yes, because if we put 1, then we're forced to have 3 and 3. That is a no-go. So yes, 2, 5 split. This 2, 5 split will then cross out this 1 for the same reason. If we put a 2 here, we're forced to have 5, 5. That's wrong for many reasons. So that's our 1. That's our 2. 1 will jump back over here. Give us our 1 down there. Why are they still holding out? They're giving us numbers on the outside. They have this spiral. Once we find like one number in the spiral, it just it like solves the rest. This pinwheel. What's the name of this puzzle? I wonder if this puzzle has a name. I'm sure there's some crossouts. Yeah. Oh, here we go. Freebie. Or, well, not freebie. I had a lot. We worked hard to get this. But 1, 2, 3, 4, 5, 6, 7. Finish the row with an 8. Cross out a couple of 8s. Two, 5. Oh, here we go. 6, 8 split. Resolves this 8, 9. That's our 9. That's our 8. Let me get that 6, 8 back. Okay. That's our 9. That's our 8. We know there's a 9 in the middle somewhere. We know this is a 2, 5 split, 6, 8 split. So this is a 4 or a 7. 2. I'm just gonna plug in 4 here. Top right. Oh yeah, why told me that. I'm gonna plug in a 4 here because I have a feeling this 4 might wreak some havoc in the middle, such that it becomes illegal. So this is 2, 3, forced by the 4. Oh, and then okay, that didn't take long. That did not take very long at all. So a 4 forces 3, 2, and 3 because this has to add up to 5. And then this was a 3, 4 split. That was a 2, 4 split. So we can resolve this as our 7 here. Bam. And this is our 4, and that is our 7. I'm glad that didn't take long. And that it worked. I can cross out a 7 there. No biggie. Hmm. 4, 6, 9 is the rest of row 2. Let me go ahead and pencil that in, or pen that in. 4, 6, 9 split. Any crossouts? There's got to be at least one, right? I guess the 4 here for the same reason as before. Yeah. Two, three. Okay. This box is this is the last penmanship we need. So I might as well pen in these last 4 squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5 boxes and 5 marks. Okay. Cross out 4, 9. Isn't row 4, column 6 the only spot for 1 in row 4? Row 4, column 6. Yeah, if these pen marks are not lying. We have a 1, we have a 1, we have a 1-5 split, so this box is covered. We have a 1, and a 1-2 split, and 1. Let us get this ball rolling. And no 8 in those row 6 pens. Let me check it out before I get the ball rolling. Oh yeah, let's get these 8s. Okay. Alright, so we found this 1. 1 forces a 4 to add up to 5. That crosses out that 3. So that's a 3, that's a 2. 2 shares a box with that 2-4 split. So this will be a 4. 4 shares a box with this 3-4 split, so that'll be a 3. 3 shares this plus sign with the 3-1 split, that's a 1. 1 shares a plus sign, that's our 2. 2-1 split in the same box, that's a 1. 1 plus 4 equals 5. 4 crosses out that 2-4 split, that's a 2. 2 plus 3 equals 5. Now resolve. Resolve conflicts. That's a 5, that's a 2. 1 and 6 down here, that's a 6, that's a 1. 8 cage left. Analyzing. 3, 5. Here we go, 3 and 5. And then 5, 1. Cross out that 1, that's a 5. 5, 5, 5, 5 in the middle here. 6, we can cross out a couple of 6s. And that's 6 too. Let's keep going. More crossouts. 4s. 4, 4. Gives us a 4 in the middle there. Top box 4. 4, 4. Gives us a 4 over here. That means that's our 9. That's our 6. This box is finished. 9 down the middle. Gives us a 7. 7 gives us an 8. 7, 8, 6, 9 split. Resolved by the 6 up here. That's our 9. That's our 6. This column can be finished with a 3, it looks like. Bam. Yep, a 3. There's probably so much stuff we can cross out. 5, 7 split gives us a 3, 5 resolution. Cross out a bunch of 5s. 9 crosses out a 9. So that gives us a 5 right there. which resolves this 5-7 split as a 7-5 solution. This 5 and this 5 both point at this 5-9 split. That's a 9. 6-7 split. Cross out those 7s. Also, there's a 7 in the box. That's our 9. That's our 8. Six, 7 split. There's some crossing out over here to do. Any crossouts over here? No. Well, let's cross out this 2 to start. And this 2. So 2, 2. That's a 2. 9, 9. That's a 9. Yeah. 6. That's our 7. That's our 6. That's our 7. That's our 6. That's our 7. That's our 6. 6. Over here. 8. 6. Resolution. 6 down here. And then 8 up here. And 7 down here. Just doing some pencil marks. That's our 6. That's our 9. That's our 7. This is our 8, that's our 7. And then we can finish the puzzle off with 6 and soak it in. Absorb. Oh, if I didn't soak it in, I could have finished before 70 minutes, but that's okay. We got it in 8. Bam. Oof. That one was, so how come this one felt like it took forever and it was 70 minutes, but this one we breezed through it, but it was 66 minutes? I don't know. The mysteries of time. Had to send the 8 really fast, it would have been a 701. It's okay. What was the name of the last one? Just puzzle, I guess. Not all of them have names. This one was called Stairs. The first one for today. This one was nameless. Although, what's the next one we're looking at? L Tetram. So we're not gonna do this one right now. We can preview it. L Tetraminos. L block, L block, L block, L block. It's all L blocks. Does that give us 9 freebies? That would give us 9 freebies. All 9 of these are given. That's the first time. That's the nicest they've been in this entire puzzle pack, by far. Not 9. Oh, there's probably gonna be some weird bend logic. There's gonna be so much bend logic going on here. Like, you know, this cage can't have 3 of the following, 4 of the following, 2 of the following. Must have 1 of the following. Like, there's gonna be so much of that going on. Is 30 restricted? Yeah, 6, 7, 8, 9. 1, 2, 3, 4. Yeah, so we'll be doing this one next time. When is next time? What day is today? Friday? So Sunday. We're coming back to this Sunday. 7 o'clock as usual. I've been going since 7 today, so I've been at it for 3 hours now. 3.5 hours. So then see ya. Yep. See ya, Alex. Those are good puzzles. And yeah, I'll check out, what do you call it? Superliminal. Seems pretty cool. Oh, and Maggie. Pretty soon, I'm going to take up some Sudoku Sunday hours to play The Witness. And don't forget about the Turing test. You might like that one too. The Turing test game. I'm familiar with the Turing test, not with the game. Oh yeah, I could even get I haven't played, well, I guess puzzles like a platformer a little bit. I was gonna say I haven't played the original Portal. I played Portal 2. I think I own Portal. I think I downloaded Steam because Portal was free in like 2004. So I think that's why I downloaded Steam. So I own Portal. Never played it. Yeah, Portal 2 was, it was pretty, I guess it was pretty fun. I don't know. I did the Portal was so much shorter than 2. Yeah, yeah, I would imagine. I feel like when I watch Portal 1, it looks like the goal is get from point A to point B however you can. And that's a puzzle. Where when I was playing Portal 2, it was kind of like, hey, there's an intended solution to all of this. Find the solution, you know. I think just get from point A to point B in a creative way is pretty cool. Alright, with that being said, I played 1, then I played 2, and I thought it was done. It's only much more. Right. Alright, how much Donkey Kong music did I have left over? We still have half an hour of Donkey Kong music. I guess that makes sense. I knew it was 4 hours long when I started. But yeah, these were some good ones today. Staircase, good puzzle. Puzzle 11, good puzzle. Not too much. You know, add up these 14 squares. Like nothing like that. Well, yeah. So I'll see you guys Sunday, 7 o'clock. Be there, be square. And I guess we'll do more killers. I took a break from killers because they're too complex. So if we do, I want to do that next killer because it looks easy, fun, 9 freebies. But I also want to do thermos, so I'll probably start with thermos to warm up. That being said,